Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Nurfazly bin Ahmad Timizi. My final year project is design of Azolla pinnata culture system for remediation of aquaculture wastewater. For the introduction, aquaculture system have two types, which is open system, example key system, while closed system is recirculating aquaculture system, RAS. Focus of study is RAS. Why RAS? RAS have many benefits, which is possibilities to decrease water use and ability to improve system hygiene. RAS have two types, which is indoor and outdoor recirculation system. For the problem statement, waste excreted by fish in RAS will generate ammonia, which is one of the most harmful wastes. In RAS, nitrification process is the main process to reduce ammonia concentration. According to Ray 2016, high concentration of ammonia will have an effect of development of aquatic organisms that are commercially grown and can decrease survival. So the hypothesis of the problem is integrating Azolla pinnata in a rust for removing ammonia nitrogen that can improve the stability of rust. The hypothesis was based on a study by Muhammad Ramli and another researcher 2018, which used microalgae to improve the rust stability. For the objective of the study, first to evaluate the ammonia removal by Azolla pinnata, and then to propose the design of rust and to calculate the capacity of Azolla pinnata to remove ammonia in the rust design based on the result achieved in objective 1. For the literature review, current situation of aquaculture has been recognized as a potential export earner after palm oil and rubber. For the rust is a technique used to recycle water used to farm fish. Component of rust have four, which is fish tank, solid removal tank, biofilter tank, and some. Water quality in rust have parameters like dissolved oxygen concentration, temperature, and pH. Fish require optimum dissolved oxygen concentration, optimum temperature, and optimum pH to grow and stay alive. For the Azolla pinnata, Azolla is a species of fern that is floating on the water. It known as a green gold mine as it has many utilization in example water purifier. For material and methods, part 1, Azolla pinnata will be captured in plastic basin using pond water. The experiment have two type of treatment, which is first treatment 10 mg of ammonia concentration pond water plus ammonia, and the second treatment 2 gram of NPK fertilizer pond water plus NPK. The treatment will be each treatment had 3 replicates and add 10 gram of Azolla pinnata as an initial weight, and 5 liter of pond water were added. The pond water must sterilize using UV light for an hour. This is a disinfection method to kill the familiar bacteria and microorganisms. This is top. This is the picture of the experiment. Top level for the pond water plus ammonia treatment, while bottom level for pond water plus NPK fertilizer treatment. This is head spectrophotometer DR4000 to measure the ammonia using salicylate method, while YSI penalty parameter to measure the dissolved oxygen concentration, temperature, and pH. For part 2, the proper design of rust. The rust will begin with fish tank and flow through the water to the biofilter tank, and then flow through to Azolla pinnata culture system that placed on the top surface area of some, and then it will return back to the fish tank. For result and discussion, for part 1, we can see that the blue line, which is pond water plus ammonia, is the more higher than pond water plus NPK. That means the pond water plus ammonia treatment is the more efficient than pond water plus NPK. Next is cumulative of weight by Azolla pinnata in two treatment. The weight of Azolla pinnata was influenced by the total ammonia removal before. That means pond water plus ammonia treatment is the more efficient than the pond water plus NPK. we can see that the pond water plus ammonia is the more weak than the pond water plus NPK. This is a graph of average plus minus standard deviation of dissolved oxygen. We can see that the pond water plus ammonia is the more dissolved oxygen level than the pond water plus NPK. This is because pond water plus ammonia treatment is the higher photosynthesis is occurred, as the high growth rate of Azolla pinnata more higher than the pond water plus NPK treatment. Next is the graph of average plus minus standard deviation of temperature. The the temperature for the both treatment is not quite difference, but we can see the day one, the temperature is the more higher, is the highest than the another day. This is because the hot temperature in that day. Next is the pH, average standard deviation of pH. You can see that the day 4, the pH was the highest. This is because the higher photosynthesis is occurred. This is a statistical analysis using one-way ANOVA to compare the means ammonia removal between two treatments, and the result is significant at P less than 0.05, while the result of weight between two treatments is not significant at P greater than 0.05. Uh, for the result of dissolved oxygen, temperature and pH between two treatments, which is significant at P less than 0.05. For the part 2, in the first trial, 4 components were selected, which is fish tank, solid removal tank, biofilter tank, and sump. For this design, the weakness was identified, which is the solid removal tank. Uh, the solid removal tank was not suitable and no modification was allowed by hatchery manager. Uh, the pipe connection at the bottom of the solid removal tank did not meet the purpose of the solid removal function. So the next design is to remove the solid removal tank and only have 3 components of RAS, which is fish tank, biofilter tank, and sump. The Azolla pinnata culture system will be captured in the top surface area of the sump to optimize the function of the sump. But I was not able to continue the experiment because the movement control order was given by Malaysian government. Next, to calculate the capacity of Azolla pinnata to remove ammonia in the RAS design. Firstly, we must calculate the surface area for basin in part 1 and calculate surface area for sump in part 2. For part 1, average weight of Azolla pinnata per meter cube was calculated, which is 252.7 gram per meter cube, so that the value can know how much average weight can fulfill surface area of sump, and we can get the value, which is 153 gram. Then ammonia removal by Azolla pinnata per day will know, which is 47.43 gram ammonia per day. The stochasticity is 10 kg per meter cube. The amount of feed per day for the fish is 2% of the biomass, which means 200 gram feed per day feed design. According to Eberling and another researcher, 2006, is one if 1 kilogram of feed in a 1 meter cube RAS, ammonia will be released with a value of 30 gram. Ammonia released 6 gram per day by fish in this design. The Azolla pinnata will be able to remove the ammonia in RAS at the rate of 47.43 gram ammonia per day. The result explained that removal of ammonia will be excellently done by Azolla pinnata, since it could remove more than ammonia produced by fish. As per conclusion, the ammonia removal by Azolla pinnata was successful as it has already achieved of the objective of the study. The uptake of ammonia was found at 0.31 mg per liter per gram of Azolla pinnata per day for treatment pond water plus ammonia, which is higher than treatment pond water plus NPK. Integration of Azolla pinnata culture system in RAS was to improve the stability of system and to calculate the capacity of Azolla pinnata to remove the ammonia. The study has shown that Azolla pinnata could be used as water purifier in example to remove the ammonia released by fish. For recommendation, the Azolla pinnata culture system can be designed to evaluate the removal of concentration of nitrate or nitrogen in aquaculture wastewater. Next recommendation, the experiment should run for a long period where the effect of Azolla pinnata to the removal of ammonia can be known accurately. Thank you.